Alright, this is Mr. Gillen, and today we are going to continue writing and evaluating expressions. This is your instruction book on page 158. It says that Jennifer buys 1 pack of orange sugarless gum and 3 packs of mint sugarless gum. I'm not really sure why the sugarless part is important yet, or if it is important, but it is sugarless gum. It says the pack of orange gum has 8 pieces. The pack of mint gum each have the same number of pieces. Okay, so it doesn't say it does not say exactly how many pieces are in each of the mint packages. Interesting. It says to write an expression to show the total number of pieces of gum that Jennifer buys. If 1 pack of mint gum has 6 pieces, what is the total number of pieces of gum that Jennifer buys? So it looks to me like we're going to be writing an expression, no equal sign, and we're trying to represent the total number of pieces of gum that Jennifer buys. And so one way that we could think about this is by drawing a picture. It says if we draw the picture of each of the packs of gum, orange, mint, 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 that will help a little bit. Below each of the packs of gum, they've labeled exactly how many pieces are in each one. The orange gum, it says specifically there are 8 pieces in the orange gum. We don't know how many pieces are in each of the packs of mint gum, but we do know that they have the same number of pieces in each one. So instead of trying to guess a number that each one has, and we can't assume anything, because we're not sure, we're going to just use a letter to represent how much each one has. So I'm going to say there are P number of pieces in mint, P number of pieces in mint again, and P number of pieces in mint again. The overall goal is to try to figure out, in 1 pack of mint gum, which has 6 pieces, what is it to, oh, sorry. Take it back. It says the packs of mint gum have the same number of pieces. Write an expression to show the total number of pieces of gum that she buys. So we're going to talk about that in a second, but really what we have is we have 4 different things that we're adding up. We're having 8 pieces here, plus however many pieces are in there, plus however many pieces are in there, and how many pieces are in the last one. And the reason we're going to do that, and we can use P for each of these unknown numbers, is because we're assuming that each pack of mint gum is the same amount. Now there's a better way to write 8 plus P plus P plus P, but I think we're going to talk about that in just a second. Okay. We could also model it this way. It says you can write a sentence describing the total number of gum pieces, and the total number of pieces of gum is the sum of the number of pieces in 1 pack of orange gum and the sum of the number of pieces in 3 packs of mint gum. So I knew to use the addition because I have something here and I have something here, and I know that in order to find out how much I have all together, I need to add. So we need to know how much there is a first amount, which we were going to call the orange gum, how much that is, and a second amount, how much there is altogether in the green gum. So this part can get a little tricky. When I think about writing the expression, it says the number of pieces of gum in 1 pack of orange gum. In this case, it's just it's almost too obvious. The expression for the number of pieces in 1 pack of orange gum is literally just 8. There are 8 pieces. Like, there's no variable, there's no operations. It just goes out right and tells us, hey, there's 8 pieces here. Number 13 says write an expression for the number of pieces in 3 packs of mint gum. So this can be done a couple of different ways. What I'm tempted to do is say P plus P plus P, which is true because that would represent the number of pieces in 3 packs. However, we could also write it as 3P. If, hypothetically, each of these had 2 pieces, I could do 2 plus 2 plus 2, which is true, or I could do 3 times 2. There are 3 pieces, or 2 times 3, either way, however you want to think of it. I better do that. 2 times 3. So there are 3 packs. So because we don't actually know how many pieces there are in each one, and we think they're just P number of pieces, instead of 2 times 3, we would think P times 3. But we wouldn't write it that way. We would actually write 3P. And I think that's what they're going to write here. So it's hard to connect that because it does look like P plus P plus P, which also would be an expression. But really, P plus P plus P is 3 times P, or 3 Ps. So we write the expression as 3P. So when we write the expression for the sum of the number of pieces in 1 pack of orange gum and the number of pieces in 3 packs of mint gum, we have the expression for orange, which is 8. We have the expression for the packs of mint gum, which is 3P. which is that entire mint gum side. So altogether, our expression could be represented for all the total pieces as 8 plus 3p. So that's to explain how you could use the expression from problem 14, which is just above, to find the total number of pieces Jennifer buys if each pack of mint gum had 6 pieces. Well, this is where things get fun. We're going to use something called substitution. And I'm not sure if the book is going to explain that yet or not. I haven't looked behind this blank for a while. So what I'm going to say is I'm going to use some substitution. So now remember that p actually represents a number. And so when we have decided what that number is, we actually replace that letter with the number. It's like changing the tire on a car. Take off the old tire, you put on the new tire. The old tire is the letter, the new tire is the number. So when we do that, we actually have to use parentheses. So I'm going to start with 8 plus 3p. And I'm going to change something about p. P represents the number of pieces in one pack of gum. So I'm going to change that. I'm going to say 8 plus 3 times, instead of p, I'm going to use the number 6. Now I have an expression that I need to simplify. What we just did was called substitution. Okay. We replaced the letter with a number, the variable with a number. And now I simplify this just like I would with order of operations any other time. I look inside the grouping symbols. In this case, there's only the number 6, and there are no operations inside the grouping symbol. So at this point, they are no longer needed. 3 times 6. Multiplication division happens before addition, so I would say this is really 8 plus 18, and the last operation, addition, would be 26. So I know that there must be 26 total pieces if each pack of gum has 6 pieces, and I know that through substitution. And you can see that they even used parentheses in the book. That makes me very happy. Right there, they replaced the letter with the number. Using parentheses, that's especially important, so she must have bought 26 pieces of gum. Number 16 says that Martina is 3 inches less than, twice as tall as her little brother. Whew, okay, let's write an expression for Martina's height. How tall is Martina if her little brother is 28 inches tall? Although this doesn't have a question mark on it, it does say it's more of a statement. It says write an expression for Martina's height. So let's start with that, and then we'll talk about how tall she is if her brother is 28 inches tall. So there's some key words here that I'm looking at. It says that she is 3 inches less than. Okay, if I was saying 3 less than 10, I would do 10 minus 3. So when I say 3 inches less than, I know that that's going to be subtracting 3. Whatever the rest of it is, I'm taking 3 away from that. And I'm using just like my knowledge in my head of when I mean 3 is less than. 3 less than something means I'm taking 3 away from something else. So minus 3 is actually going to be the back part of my expression, even though it's the first thing that's stated. It's one of those English language kind of things. Okay. It says she's 3 less than, twice as tall as her little brother. Twice as tall. That means twice as big, 2 times, as her little brother. Now, we don't know how tall her little brother is. And so that's the unknown. It doesn't say a number because obviously this is a real life situation. But we don't know how tall her brother is. So let's use a variable for her little brother. The common, most popular variable is x. Sometimes if you're talking about bananas or apples, you could use like b's and a's. But in this case, there's only one variable. We'll just use x. Okay, her little brother's height, we're going to call x. So she is 3 inches less than whatever her little brother is times 2. Twice as tall as her little brother. So we don't know her little brother, so we're going to call that 2x, twice as tall as him. X represents the height of little brother in this case. It's important to know what our variable stands for. Okay, this is my expression, and I know that x represents the height of her little brother. And now, so I need to make sure that's part of my answer because that, even though it doesn't have a question mark on it, that is still part of what needs to be done. It says, how tall is Martina if her little brother is 28 inches tall? So again, we're going to use this thing called substitution. So instead of x, I know how tall he actually is right now. I can take out the letter and put in the variable. So it's like I'm taking, I won't write everything exactly the same except for where the letter used to be, the variable used to be. I'm going to put empty parentheses. And you see how this is squished together? This is still squished together. I don't need to put the little dot in there. I already know it's held together with multiplication. I'm going to put 28 in there. That's how tall he is. The nice thing about an expression and the usefulness of this is that in 2 years he might no longer be 28 inches tall, but the relationship between Martina's height and his height might be the same. So we could put the new number in each time. And so it varies, it changes depending on the situation. It's called a variable. Okay? 2 times 28 is 56. Order of operations. Technically, order of operations would say, I better do it correctly. Order of operations would say, look inside the parentheses and complete operations inside the parentheses. Well, in this case, there is no operations inside the parentheses. It's just the term 28. So really, we don't need the parentheses. We need to start our substitution with them. But if there's no operations inside, we can go ahead and get rid of them on the next step. 2 times 28 is 56. And then 3 is the last operation. The reason I multiply before subtraction is because of order of operations. We do multiplying and dividing before we add or subtract. The only operation left after we multiply is subtraction, so I know that she must be 53 inches tall. Let's see if we were correct. Alright, we decided, okay, so in this case they didn't use the letter x, they used the letter b because brother, I'm assuming. So 2x minus 3 or 2b minus 3, and she must be 53 inches tall. So there are 2 parts to that, even though there was only 1 question mark, so make sure you're reading carefully. Tracy has 5 cans of vegetable juice in her refrigerator. 4 of the cans each have 6 ounces of juice. Write an expression for the total ounces of juice Tracy has in her refrigerator. If the 5th can has 12 ounces, what is the total ounces of juices Tracy has? So it says to write an expression, and it doesn't have a question mark on it. It's telling you need to do that. So it's part of your answer still. So if she has 5 cans of vegetable juice in her fridge, vegetable juice. These are all vegetable juices, okay? And 4 of those cans each have 6 ounces of juice. 6 ounces, 6, 6, 6. It says to write an expression for the total ounces of juice Tracy has in her refrigerator. Now, it only says that 4 of them have 6 ounces, so we cannot assume anything about the final can. It might be like tempting to say that it's 6 ounces, but it doesn't say anything about the size or anything like that. So I can't just assume. I have to. It's what we call an unknown value. We don't know, so we must represent it with something that can change depending on how much it actually is, and that thing is a variable. So again, we would have our 2 models, and we would have a sum in between, and the left-hand side of our models would represent what we do know, 6 plus 6 plus 6 plus 6, otherwise known as 4 times 6, or 6 times 4. You might even see it just say 24. We're going to find out in a second. The last part, though, we don't know. We're going to call it V because we're talking about vegetable juice. So that represents the unknown portion, just V. So altogether we have 24, and V, the expression could be 24 plus V. If the 5th can has 12 ounces, okay, that's this guy right here. If he is 12, what is the total ounces of juice Tracy has? Well, it would be 24 plus. Remember, when we substitute, we just take out the letter, we put in parentheses, 12. Order of operations says do what's in the parentheses, and there are no operations. So now it's okay to take the parentheses away and complete our operations. I think she has 36 ounces of vegetable juice in her fridge. And it looks like that is correct. Looks like they use J instead of V, which is fine. It is an unknown number, so we use a letter called a variable. 18 says that Brian says that the expression 8n plus 2 is equal to 83 when n equals 1. Explain why his answer is incorrect. Well, Brian, unfortunately you are incorrect, and here's why. If n equaled 1 and we substituted for n, and we put the value that he believes it to be in there, we would do order of operations. Looking inside the parentheses, there are no operations, so it's not necessary to have the parentheses anymore. Multiplying, I don't see any exponents, so multiply and divide, then add and subtract. I think, unfortunately for Brian, we only have 10, not 83. And so when he says that it is equal to 83 when n is 1, it is very confusing because I'm not sure what the heck he was doing. Brian, you're way, way off. Oh, I know what Brian was doing. Naughty Brian. He thought that 8n meant if you put the 1 in, that just makes the number 81. Okay, which is not really how variables work. So what he thought was 8 with a 1 behind it makes 81. That's not how it works, boys and girls. Okay. Then he added 2 to get 83. So it should really be 10, which is what we showed. Okay.